So just to introduce Claudia, I first met her fairly recently, really, through the CERTO project, but I know she's collaborated with lots of PML staff, including Steve Green and Stefan, for many years. Steve says he's very sorry not to be able to be here today, but he's involved in the science team meeting. So unless there are any objections, we'd like to record this meeting, because there's actually quite a few people have expressed an interest who'd like to see the seminar. So Claudia is a research director at the Italian National Research Council Institute for Remote Sensing Science. If anybody would like to hear the Italian version of that, please ask Claudia, because I can't possibly repeat that. She has a degree in environmental engineering and a PhD in geodetic and topographic sciences, both from Milan. So Claudia's research focuses on processing satellite data to determine water quality indicators, and she's been working on harmful algal blooms and investigating the impact of climate change on lakes. Claudia is a member of the CHIME advisory group, which is the Copernicus hyperspectral imaging mission for the environment, and also PRISMA, which in English translates to the hyperspectral precursor of the application mission. She's also a member of the IOCCG Committee, which is the International Ocean Colour Coordinating Group. And today we're really looking forward to, she's going to talk to us about the evaluation of PRISMA products for aquatic environments. So without any further delay, I'd really like to hand over to Claudia. Again, as I said before, if you think of any questions throughout the seminar, please type them in the chat and we'll have time at the end to go through them. So thanks again, Claudia, for joining us. We're really looking forward to hearing what you've got to say. Thanks again.
Thank you, Dan. Thank you very much for this nice introduction. Good morning, good afternoon to everyone. I'm very glad to be here today, and thanks again for inviting me to take the opportunity to present the PRISMA mission and provide some updates and some potentiality of PRISMA for water quality mapping. Okay, so as I said, this seminar will provide you an overview of PRISMA products for the specific application of aquatic environments. I would like to thank co-author of this presentation, my colleagues here in Milano, Mariano, Alice, Andrea, and Salvatore, as well as people from the National Research Council, Institute of Marine Sciences. I do know Federica and Vittorio should be also attend the seminar, so please provide your question and comments also to them. We are very happy to answer any question you may have about PRISMA. So thanks again to the team working with me in this project. Okay, to proceed. Okay, oops, too fast. So the outline of the presentation is given in this slide. I will show the main characteristic of PRISMA, which in Italian stands for Precursore IperSpettrale della Missione Applicativa. This part will include the characteristics and the performance of the missions after 2 years of operation, how to discover and assess the products, and an overview about products and tools which enable you to navigate into level 1 and level 2 products. I will then enter more into the topic of aquatic ecosystem application by showing some example of PRISMA, which is able to provide some water quality parameter mapping. Being a CERTO seminar series, I'm glad to present also some analysis of PRISMA imagery for study areas of this H2020 project, and I will end with a summary and conclusions. So the main characteristics of the mission are given in this table. These are the nominal values of the mission, for which you may note the capability of PRISMA to acquire standard imagery of a size of 30 by 30 kilometers, but also the system can acquire full resolution data up to more than 1,000 kilometers. So this is an example of the street mode acquisition over Chesapeake Bay for 3 by 3 imagery over the area. And you may also note the signal to noise ratio of the mission. Of course, this is an hyperspectral sensor operating from the visible to the shortwave infrared part of the spectra. And the signal to noise ratio is optimized for providing data available for a lot of application, not necessary over water, for which the performance of radiometry may be reduced. Anyway, we will see later on that based on such signal to noise ratio, we are able to use PRISMA also for water application. It is also interesting to note that the nominal repeating cycle of the sensor looking at nadir over the same area is of 29 days, but the platform on which PRISMA is mounted has a capability of tilting, so the sensor can be tilted, and this enhances the relook time capacity of less than 7 days, providing more data over your study area for particular needs. So the mission started quite many years ago in the past, but we're happy to say that finally on 22nd of March of 2019, the sensor was launched in the space, and starting from that date, it is entered in the commissioning phase for 6 months later provide operational free open data. So this is the coverage of the PRISMA tiles that have been acquired during the commissioning phase, in which all the system performance were cross-checked. So this is an overview of across the globe of the PRISMA acquisition, which are available in the catalog after 4 months from the launch. This is of course covering all the Earth's surfaces, include both land and ocean masses, and this is how the tasking was accomplished during the commissioning phase. After that, after this commissioning, the mission starts to work for the entire community. And for building the catalog that we will discover later on, PRISMA has been configured to work in 2 operation modes, which we name it as a background or foreground. In the background mission mode, the PRISMA optimize the system resource usage and generate imagery to fill up resource which is still available after planning the user request. So it starts to compile the catalog based on a scheduling mission. Then we do have this foreground mission capability in which user can task the PRISMA for on-demand request. And in the foreground mission, which also has a higher SAS of degree with respect to the background, we have inserted the covering of some sites for which the Mission Advisory Board of PRISMA provide to the Italian Space Agency the interest about the community who are interested in hyperspectral data. And for instance, we have inserted in this foreground mission capability the systematic acquisition of PRISMA over, for instance, the Aeronet ocean color sites in order to start to build catalog for which we do have reference in situ measurements as a comparison. So this is some statistics after 2 years of the launch. About 800 licenses were activated. You may see the composition of the users with respect to the nationalities. We do have, of course, a pretty high percentage of Italian users, but also from the other countries, a community which is still growing. The system, when is fully exploiting its resources, allows planning, acquisition, and download of about 200 spot imageries per day. So this is the potential of the system for any kind of users. So just an overview of an imagery from PRISMA. This is one of the first that was acquired that I'm always happy to share and to show. This is the Venice Lagoon, in which you may recognize the city of Venice, from which you may already appreciate the capability of the system to capture the variability of optical water inside the lagoon, over the wetlands, as well as in the open sea facing the lagoon. PRISMA, interesting to note, also carry on board the panchromatic camera. This improves panchromatic acquisition over the co-registered hyperspectral data cube with a spatial resolution which is of 5 meters. So this is really enhanced the capability of PRISMA in looking at finer high resolution data. For instance, zooming in into the Venice city, you may see here also the shadow of the Tower of San Marco in Venice Square. So to discover and access the PRISMA data, you need to register to the system to agree on data policy. And after compiling a pretty easy form, you can access to the data. After having your credential, you can access according to two systems, the catalog and the new acquisitions. So we do start with the catalog, in which you can simply search your imagery according to a region of interest that you can define as wide as you like, and also, of course, very close to your area of interest, in which you may select the temporal range in which you would like to find PRISMA data. And for instance, in such data research over the entire globe, I would say, for just one day, I have discovered about 130 products. In April 2021, this catalog was already listing these 7,000 images all over the world. So the catalog is now pretty high populated. You can also task PRISMA for some user needs. If you do not find your area of interest into the catalog, if you wish to plan a specific acquisition, you can enter into the portal by clicking in new acquisitions. And here you can select your area of interest, in which you can ask the tasking of the data. There are a couple of tips that may provide you a more success of acquisitions. First of all, I would suggest to enlarge your validity time range in which PRISMA tend to acquire data as longer as possible, which means the 29 days of repeated cycle, while as a standard value, the acquisition provide you 2 weeks window. And another tip is that at the time of the contextual processing order, you select at least one level of processing. So as soon as your imagery has been acquired, you will be notified by email that you have the possibility to download the PRISMA products at the level of processing you have asked. So by using this functionality, you can also, of course, specify the maximum looking and angles, because the tilting capability. So for instance, if you would like just to have nadir view images, you can restrict this range, which of course decrease the probability of success of your tasking. And you can also, of course, task with respect to some predefined illumination conditions. Recently, the agency has also released a PRISMA, what is called PRISMA Prefeasibility tool, in which for your area of interest, you can know in advance which will be the time of overpass of PRISMA of the selected area. So you can maybe try to synchronize the PRISMA acquisition with some fieldwork activity. In this case, for instance, if you put as a starting epoch the 12th of November up to the 12th of December of this year for a certain latitude and longitude, which will be somewhere here in Italy, for these viewing conditions and illumination condition, the system will provide you which will be the sensing opportunity of PRISMA in this time window. Providing you the day of acquisition, and also in case there are some problem, also a notification about the reason why, for instance, this sensing opportunity will be not considered. So having said that, into the portal, you can also look at some documentation about the data and the mission. By clicking in documentation area, you can also discover and find some specific information in the documentation area. So when you look at the PRISMA products, you may see that there are different levels of processing. Level 0, which is not provided to user, which is an internal processing from the industry to provide level 1 data into the catalog. At this level, level 1 data, the first level processing, which is accessible to everyone. Level 1 provide radiometrically corrected and calibrated radiances in physical units, both for hyperspectral cube and the panchromatic data. Then we do have 3 levels of processing with respect to level 2B. All of them are corrected for the atmospheric effect. In particular, in level 2DC, you also find some ancillary products, which are the results of the atmospheric correction about the aerosols. And finally, the level 2D products, which are the geocoded version of atmospherically corrected hyperspectral and panchromatic data. So you, as a system, is continuously updated with respect to the flat field calibration targets. There are different levels of processing which are provided by the system. So each time you will download a PRISMA products, for instance, in terms of level 2 products, you may check the level of processing you are downloading. And in this graph, you show the differences between the different processing levels that from the closing of commissioning phase up to now have been updated into the system, trying to, for instance, resolve the first problem we discovered about the 0 values for a very turbid or low reflectances target, such as waters. So for instance, you do see in green the first level of processing in which many spectra were given as a 0 simply because the reflectances was wrong or below 0. So the system provides you reflectances as 0. So the improvement which has been provided thanks to the ongoing calibration activity performed by the industrial partners of the mission. Meanwhile, the community has worked on providing some interesting tools for reading the products. I will show later on some of these, which basically allow you to open the level 1 products, which are provided in HDF5 format. So any kind of importers is able to read this format, is able to read PRISMA products. While some other tools are even more focused on PRISMA. The first, which has been developed by our colleagues here at CNR, is the PRISMA Read, which is available in R, which provide the functionality for automatically extract reading level 1 and level 2 PRISMA products and convert them into more common formats such as NV or GeoTIFF. And it also provides some functionality for instance to compute spectral indexes, which are, of course, maybe served also for vegetation studies and application. So PRISMA Read is available, as I said, in R. Those are the functions which are included, which enable you, as I was saying, also, for instance, to convert this HDF format in NV or GeoTIFF. It also is able also to extract from this imagery the ancillary information that we may like to have, such as the illumination and viewing condition that maybe are used for atmospheric correction of data. And as I was saying, it enables also to compute some of the most common indexes which our colleagues are using for mapping soil and vegetation here at CNR, which have been integrated in these routines. Recently also, thanks to the collaboration between the Italian Space Agency and the German Space Agency, which is following soon a system similar to PRISMA, which is the ENMAP. Thanks to this collaboration, also the ENMAP box, which is the hyperspectral toolbox dedicated to this future satellite mission, is now able to ingest PRISMA data. So this is an example over Lake Trasimeno to extract level 2 spectra from PRISMA imagery. And interesting is the accessory tool to Nmap, which is the Python tools which are combining Nmap, for which you may recognize here the atmospheric correction water polymer, which should be able to correct Nmap products for atmospheric effect, and which may also see some developed for PRISMA soon. As I said, PRISMA is a full imaging spectrometry which covers from visible to the near infrared to the shortwave infrared continuously, which provide, of course, a large potentiality for a variety of system and ecosystems. In particular, for water application, what I will show later on is focusing on the first visible part of the full data range covered by PRISMA. Already at the time of the commissioning phase, the Italian Space Agency was able to show at Le Bourget in 2019 some potentiality of PRISMA for water quality mapping, for instance, in mapping the bathymetry, the transitional system in which we define salty water and freshwater mixing water, mapping turbidity in Lake Trasimeno. You will see a lot of examples on this lake, and also the garbage patch of plastic in the ocean, which was captured by PRISMA. So more specifically, I will show you now some evaluation of this PRISMA product for aquatic application. In particular, the analysis we did in 2020 about the evaluation of top of atmosphere spectral radiances, an evaluation of optical depth, and most interesting, the evaluation of atmospherically corrected products from PRISMA. All of this evaluation is based on reference in situ measurements that have been provided by a variety of system and colleagues. First of all, Aeronet ocean color, but also new devices which differently from Aeronet are hyperspectral sensors, so more comparable in terms of spectral setting for to be compared to PRISMA, such as those provided by HyperNet, so WISP station, as well as a lot of fieldwork campaigns. So this is an overview of some of PRISMA products in correspondence of Aeronet ocean color sites, which do cover both coastal open waters and some lakes, in which we were able to evaluate the level 1 products as PRISMA was serving over those sites. So we use in situ data from Aeronet OC or from hyperspectral device that we simulated with the 6S version code to the top of atmosphere radiances. Those data were also compared to Sentinel-2, as everyone thinks that PRISMA is a good data when it works, of course, in synergy with operational sensors such as Sentinel-2 for comparable spatial resolution, but also to Sentinel-3, which has more comparable spectral setting. And so this is why we are also always considering PRISMA in synergy, because PRISMA is just a demonstration mission, not used for operational application. With respect to this analysis, we are now able to also, if everyone is interested, to run this script in air for simulating the top of atmosphere radiances with the 6S version, with the 6S vector version. We are now running the last version of the code, which is 2.1, and this tool is also available to everyone thanks to the virtual lab we are running in another H2020 project, which is called Brainwater. A more detailed analysis I presenting now, thanks also to the work of our student Andrea, in which we extend the evaluation of level 2 products over more Aeronet ocean color sites, because meanwhile more data were available. And over this side, we start to evaluate the level 2 products as with respect to Aeronet in situ data. But of course, also in this study, we were including hyperspectral sensors such as the WISP station over Trasimeno, and I will show you later on also the one mounted in Acqua Alta in the fronting the Venice Lagoon. Here again, for some of these sites, we were able also to compute the signal to noise ratio. So we extend the analysis of level 2 products over all of these sites to compute the signal to noise ratio according to finding the homogeneous area, as in the paper, in an old paper from Vettel and Vittorio as well. So we did find all of this homogeneous area over the PRISMA 30 by 30 kilometers products, in which we extracted the mean value plus minus the standard deviation. We did plot this signal to noise ratio from PRISMA with respect to Sentinel-2, again to see the potential of PRISMA in synergy with Sentinel-2. And we do see that apart for the first band of Sentinel-2, which has a coarser resolution, all the other Sentinel-2 corresponding SNR were matching well the PRISMA. So this is again a confirmation on how PRISMA can provide synergic data with in addition to Sentinel-2. We did compute also environmental noise, which is also an approach developed by Vittorio and Arthur Decker in the past. Those are the corresponding environmental noise for all the PRISMA imagery in which we did find homogeneous area, and nicely to show that overall the PRISMA products as it is without any convolving function is already providing a level which is below this threshold, the 0.1, which is suggested by Vittorio and Arnold Decker in 2003 as a threshold for which is required to provide, to retrieve water quality mapping. So at the time of that period, it was necessary to deconvolve the imagery, the spectra, to reach this thresholding level. PRISMA is already below this threshold, so the opportunity for water quality retrieval are already in PRISMA without any imagery convolution. PRISMA also serve ancillary products as outcome of the atmospheric correction. So this is a very rough scatter plot between PRISMA aerosol optical depth with respect to those measured by Aeronet. Again, for all the PRISMA site in which we do have Aeronet ocean color data. The scatter plot looks pretty nice over there, but we do see some not closing data with respect to the one-to-one line. Of course, this is very rough and not robust analysis. This analysis is ongoing to extend this matchup not only over ocean color site, but covering all the Aeronet in order to have more matchups and try to conclude something about this comparison. Finally, the things which is interesting more, the level 2D products evaluation, in which we did compute the remote sensing reflectors, simply dividing the reflectances we did find in the level 2 products by P. Those are some comparison over, again, Aeronet ocean color sites, in which for some of the spectra, level 2 products are already producing a nice match. For some others, such as here, the site in Venice is not matching well at all. In some other cases, there is a bias. In some other, the matchup is much better. So again, from this graph, we may conclude that for some water type use cases, the level 2 products are already matching pretty well the in situ reference measurements. For other sites, those data do not meet the requirements, so some dedicated atmospheric correction seems required. So with respect to this, we are investigating some other schemes of atmospheric correction, starting from level 1 PRISMA products. In particular, we have experience in using ATCOR, which has been developed by RSES, Swiss company, which is a spin-off for University of Zurich. Those tool is common to the land family atmospheric correction schemes, such as FLASH or the 6SV code. We also share data and a good collaboration with Kevin Radin and Quentin Vallemont for trying to setting up Acolyte for correcting atmospheric correction, for correcting PRISMA data. And of course, we do have here much more software that can be used for atmospheric correction of PRISMA data. I already mentioned Polymer as part of the EnMAP toolbox, but of course in a recent review from Heidi Drissen you may find more. So some results were performed with Acolyte, which was run by using this setting. So here you may see all the setting we did configure in the configuration file of Acolyte, in which we try to estimate the reflectances and the remote sensing reflectances by using Acolyte, and also the glint correction. So this is how Acolyte was working, and those are some results. Those with this is a very first preliminary shared we did with Quentin during the commissioning phase of PRISMA, in which he was trying to setting up Acolyte for ingesting PRISMA, in which we already see the good matchup between PRISMA, which was resampled at the same resolution of AeroNet OC in situ data with respect to the correction of Acolyte. As I was saying earlier, also SNAP, which is able to read HDF5 data, is of course a tool for which you can discover and play with PRISMA data. More recently, Quentin also shared with us another correction, this time using hyperspectral in situ data from the Panther, still in the region, in the Zeebrugge region, where they have all the device for in situ measurements, in which for another imagery of 2020, he provided to us the correction did with Acolyte with respect to in situ data, where you do see a nice agreement apart in the blue wavelengths, where also we do have a lot of problems with respect to the signal to noise ratio. So everything is suggesting that the first bands of PRISMA are not usable. A similar exercise run by Alice recently for Lake Trasimeno, so the use of Acolyte with respect to the in situ measurements collected in this case by the WISP station, in which with respect to the level 2 standard PRISMA products, Acolyte is reaching a better closure with respect to in situ data. Another tool I was mentioning is ATCOR, in which we do have a lot of experience, and also here an example on how ATCOR was providing us a better closure with respect to the standard level 2 PRISMA products. Of course, these are the best example. It's not always happening like this, but anyway, in case level 2D products do not work well, we may investigate, the message is that we may investigate further atmospheric correction schemes, those more dedicated to water, such as Acolyte, but also the one used in land application. Okay, then we turn to the last part of the presentation about some mapping. Again, I'm happy here to say that, sorry, there is an overlap between the figure, but already in some years ago, we were able to work in a FP7 project, which was called Inform, on defining the algorithms for the future hyperspectral mission. So at the time PRISMA was not launched, but was already planned by the agency. So this document is still very relevant to be used as a reference for playing with PRISMA data. In that document, in particular for water quality retrieval, we were defining two approaches. The one which use spectral features on the reflectances data to map a concentration of biogeochemical products, such as band ratio, in which, of course, the hyperspectral data provide us the possibility to really pick up the position of the peak and of the dips of the spectra with respect to the wavelength, which is, of course, changing depending on concentration, as well as the bioptical family, which is the full inversion of a bioptical model. In particular, and then we have also a lot of nice update about algorithms for hyperspectral data, again in the paper from Heidi. A more focus on the work we are doing here at CNR. So Bomber is one of these tools which enable with an optical inversion procedure to invert a common 4 components bioptical model, which have been defined and used a lot in the past. Bomber include a module for both optically deep and optical shallow waters. So we're using this, and I'm happy to say that the Bomber may be amended and improved thanks to the work we did on Sentinel-2 for the shallow water mapping, and then thanks also to a project we do have now running with the Italian industry to adapt the Bomber and other algorithms for the specific proper processing of PRISMA. So these new tools developed by the industry should improve Bomber based on the state of the art and provide again mapping for both optically deep and shallow waters. And we do have also the, as I was saying, the family of algorithms that works with the position of peak and dips with respect, for instance, of the position due to the chlorophyll A concentration or the phycocyanin pigments, in which depending on the concentration, the position of the peak or the dips move. So we can really pick up the band ratio depending on the position wavelengths, which is more sensitive to this parameter. Similarly, for instance, TSM, we may switch algorithm across a continuous wavelength. So the approach which has been developed and successfully applied, for instance, to Sentinel-2 can be even much more tuned thanks to the continuum spectra. So based on these algorithms, we are able to provide some mapping to demonstrate, for instance, the simultaneous list mapping of chlorophyll A, total suspended mapper, and sedum in Lake Garda, a large deep lake we do have in Italy, as well as the simultaneous mapping of submerged macrophyte in the shallow part of the lake. In Lake Trasimeno, a lake we do have in central Italy, again using Bomber, here we do have the simultaneous mapping of chlorophyll A, total suspended matter, and sedum, for which we do have some in situ data as a comparison. This is another example for a very interesting lake in Australia, in a project we are sharing with CSIRO. This is Prime Water, for which again the continuity of PRISMA data provide nice features to map a different type of phytoplankton blooming in that lake. And within that context, there is also ongoing work with the tool which has been used since a while from CSIRO, which is the adaptive linear matrix inversion method to be used with the PRISMA data, as well as in collaboration with the Nima Palavan group, also the application of a recent machine learning model they published, which is able to ingest hyperspectral data such as PRISMA and ICO. So with respect to that, this is the paper I was mentioning, for which this improved mixture density network machine learning method has been demonstrated with PRISMA data for the hypertrophic Curonian lagoon, which is also part of the CERTO project, as well as in the turbid Lake Trasimeno, for which you do see the comparison of this method with the state of the art, in which similar results are provided in very eutrophic water bodies, but not in turbid lakes. So again, this is a nice tool which is available for mapping phycocyanin from PRISMA imagery. And this is another example on estuary. This is a nice imagery facing the Po River in Italy with the North Adriatic Sea, in which it seems that a coccolithophore bloom is happening. Here again, the variability collected by PRISMA. So in this case, we again resumed the use of chromaticity. We simply apply the the filter response function of the hour high to convolved PRISMA imagery. We cross-check this approach with Hans van der Hoort, who did a nice work on chromaticity for computing the X and Y coordinates from multispectral data. And he confirmed that with a simple convolution of an hyperspectral sensor to the spectral response of I, you're able to compute the chromaticity. So you do not have to approximate with the coefficients as used in the multispectral data. And here again, our PRISMA for this imagery showed the different X and Y chromaticity in the Locci diagram, where the coccolithophore are close to the white point, which is defined in the chromaticity plot. Colleagues from the Marine Science Institute are also an ongoing activity to try to apply the QAA approach to estimate phytoplankton and recognize the pigments of coccolithophore from PRISMA data. So try to conclude on CERTO study areas. We tasked some PRISMA imagery, for which here you do see the true color composition in Tago, in the Venice Lagoon, Curonian Lagoon, both of these already seen, as well as in the estuary of Danubio. And here some spectra in which again is demonstrate the capability of already level 2D products in outline the peak and dips depending on the optical condition of the waters at the time of the PRISMA overpass. So this is the case of Danube. This is the case of the Tago estuary, in which, for instance, you may see that the last station, number 5, is pretty low in intensity because it's quite blue waters. And here again, what is happening in the Venice. A focus on Venice, of course, because there we do have a lot of instruments which are able to provide us reference data to evaluate PRISMA. So there is Aqua Alta, in which since the last century there is IREA sites. Now, more recently, hyperspectral sensor has been also positioned on that platform. And moreover, the lagoon is part of the CalVal plan of the validation plan of the agency to qualify the level 2 products over different sites in Italy. And of course, thanks to that, we are also running a lot of fieldwork activities in coincidence to PRISMA overpasses. For these sites, we do have a lot of matchups between in situ data and PRISMA overpasses, for which the group of Federica has produced a nice work indicating how the different processing level is improving with respect to the in situ data, or is improving, then is deviating again. So is monitoring the status of the processing with respect to in situ data. And this is done for a lot of matchups, and with respect to the statistics, we do compute the classical metrics to evaluate this data. And recently also Federica and their group are running Acolyte in order to, with different setting, to try to reach best closure with respect to in situ data. For which, for instance, now the hyperspectral sensor, such as those mounted in the platform, such as Pantir, are providing very important reference data. An example of mapping also for the lagoon with the shallow water products we generate with Bomber, the depth and the coverage of macrophytes from PRISMA imagery. A last example on the Curonian Lagoon for PRISMA, in which again the variability of different region of interest is reported in this slide. and for which, again, here the acolyte has been tested and evaluated with respect to in situ data. So here we do have the standard products, the PRISMA level 1 corrected with acolyte and the PRISMA level 1 corrected with ATCOR. I would say that those waters are pretty easy to correct for the atmospheric effect, as we do have a nice matchup all of the three satellite products with respect to in situ data. And also here we are producing some mapping in addition to the Falco-Cyanin paper, in which, for instance, we did compare the classical 3-band ratio approach by using the 3 bands of Sentinel-2 with respect instead to the specific bands of PRISMA, really picking up the position of the peak and of the local minimum, and in which you may appreciate the improvement taken by PRISMA with respect to in situ measurements. Finally, I would like to mention some supporting studies. This year there's been a very intensive airborne campaigns from JPL colleagues. Aviris was flown also into Italian sites covering water stuff, Lake Trasimeno and the Venice Lagoon, for which we do have Aviris data and nice matchup with in situ data and also some satellite, but also spaceborne image hyperspectral data. For instance, in case of Trasimeno, we are already evaluating the level 1 products of PRISMA with respect to the simulation of WISP station and the simulation of Aviris, both of them with a 6S code in comparison to DASIS and PRISMA. And this is a similar comparison for level 2 products corrected by us or served by the agency. So to summarize, I'm happy to say that the satellite was successfully launched and the mission is well performing. Level 1 product seems comparable to in situ data and also to imagery data acquired by synergic missions. The evaluation of aerosols is an ongoing task, which maybe help us also to understand the reason of the mismatch between the level 2 products and the reflectances. Again, the level 2 products evaluation, as I was showing, has some degree of accuracy with respect to in situ data, and the nice development of, for instance, of acolyte helping us a lot in providing a better closure with respect to in situ data. And I'm happy to say that also PRISMA can be used for water resource mapping. So in general, PRISMA is also, along with other imaging spectroscopy systems such as DASIS, Gaofeng, HyperScout, is of course a demonstration which is of a significant global advance in hyperspectral remote sensing, and it also supporting the developments of future missions such as NMAP, PACE, CHIME and SBG. And everyone, of course, is more than welcome to use PRISMA. And I'm most happy to advertise this summer training for students who are interested in learning more about hyperspectral remote sensing in general. So I wish to thank all the supporting project and of course all of you for listening. Thanks.
Well, thanks so much, Claudia, for that really interesting presentation. I must say I'm always amazed by how much detail we can see from satellites and how much we can learn about water quality from these. Does anybody have any questions or any comments they'd like to make? I see, Peter, you've got your hand up. Would you like to say something?
Yeah, you mentioned the PACE mission from NASA that's coming in a couple of years. Do you know how the characteristics will compare between the two?
No.
I believe PACE actually is lower resolution, so but yeah, maybe more frequent coverage. But whether you looked into that at all?
No, yes. PACE, of course, is coarse resolution, high frequency in time, and the link between the activity of PRISMA and PACE so far has been mediated by SBG teams, because SBG is the other NASA mission which has similar characteristics to PRISMA in terms of spectral setting, revisiting time and pixel size. What we may investigate with respect to PACE is that PACE has a spectral setting which can be easily modulated with PRISMA because it has lower bands, and so we may use PRISMA for that. And of course, we can reduce the spatial scale of PRISMA to simulate the coarser spatial resolution. So could be used as actual data to maybe provide some demonstration until the mission will be launched. But this is the only link I do see so far.
Okay, thanks.
You're
I
welcome.
didn't quite catch. You said there was a mission that was more comparable. Did you say SBT?
SBG, yes. SBG is the soil biomass geology mission by NESA, which is the follow-on of ISPIRI, that was the hyperspectral sensor that was supposed to take the place of Hyperion in the past, but then ISPIRI was evolved, and now it's called SBG. SBG has, with respect to the visible near-infrared shortwave domain, has similar spectral setting of PRISMA, but SBG also as a thermal camera on platform, so it also enables to provide more application. I'm thinking about evapotranspiration, those kind of stuff. But the idea is that in the future, PRISMA next generation may cooperate with SBG and with NMAP, so all of these hyperspectral sensor may increase the frequency of revisiting time due to the similar characteristics. So the agency are thinking to place the orbits in synergy to try to increase the temporal resolution of this hyperspectral mapper.
Thank you.
Welcome.
That's great. Does anyone else have any questions or comments they'd like to make? You can write them in the chat if you'd rather.
Yeah, sorry. Yeah. Well, first of all, Claudia, sorry, I missed half your presentation because I came out of another meeting. So now I'm very, very scared to ask a stupid question. For the CERTO areas where you described, we now have a bunch of hyperspectral radiometers in place. Are you planning to do a similar comparison to some of the ones you showed against those triospace systems for those sites? Comparison against PRISMA, or is this finished?
No, this is ongoing. This is still ongoing. I was saying that for the CERTO study area, we do not have so many images so far, or maybe I was not even showing that, but I know, apart of Venice, of course. Venice is super well documented because we do have also synergic activity with the Italian Space Agency there. But for the other three, I would expect this is an ongoing work because we do have to collect more PRISMA data too.
Okay, great.
Thanks.
Stefan, I think that in the Tagus, since we just did a CERTO campaign here, I think that somebody actually asked for some PRISMA data, and might be, I think, Mariana Soppa from a different institution, from Alfred Wegener Institute, because she was also participating on our cruise. I think she actually requested some PRISMA data to compare with the radiometers. One of them is the one that you sent to us. So maybe in the future we'll have some kind of comparison.
Yes, maybe to this point it's interesting to look at this pre-feasibility sensing opportunity of PRISMA, so you can know in advance when PRISMA can acquire data over your study area, try to synchronize in situ activity with the task. I think I will leave the slide so everyone can find the links who are interested in.
Following on Stefan's comment and also on something that Claudia mentioned during the presentation, there are 2 points to make. One is that, Stefan, if you have a continuous acquisition at those sites, that's even a further reason for Claudia to make sure that the CERTO sites are continuously acquired. And this is a task that we are taking along within CERTO and within our other PRISMA fund, ASI fund activities. So we also welcome as much validation data as possible. And also within the dedicated hyperspectral work package at Wave CERTO, there is obviously an interest to try and further develop and test some of the examples that Claudia showed for the various algorithms. So obviously the cyanobacterial features come as a clear, sophisticated product, or the particle size distribution, so the more advanced product compared to the chlorophyll that more or less one could argue that is an overkill to do it with fully hyperspectral.
Good point. And I didn't say, but we've not really put any effort yet into advertising that the data exists, even though they are now publicly available and freely available. One of the things we were wondering is whether we should provide these in situ reflectance data set quality controlled and already resampled to the sensor spectral response functions. Be happy to do that for PRISMA as well, I think. Is that easily available? The SRF of PRISMA?
Yes, they are. The thing is that depending on the calibration stuff, so the version, the band center and the fluid at maximum can slightly change during the time. So you need to keep track on that, but then of course they are available there.
Yeah, that's even more reason to do it upstream, actually. Yeah.
Okay, yes.
Okay.
There's a question in the chat from Irene saying, is there going to be a PRISMA 2?
Yes, it will be. It will be PRISMA second generation. Yes, apparently the mission requirement documents is drafted, so it's under development, and yeah, the timeline should be less than ending phase of PRISMA, which is 5 years. So apparently, in less than 5 years, should be another PRISMA flying. We will see. We do hope it's not taking so long as the first one.
Which is unlikely not to be called PRISMA, but called ISMA, given that the PR stands for precursor. So, you know, we're gonna see how they call it.
That's brilliant. It's nearly 1 o'clock. Does anyone have a final question they'd like to ask Claudia? No. Okay, I think we're all looking forward to our lunch. So once again, so thanks so much again for coming to talk to us today, Claudia. That was really enlightening. We've taken a recording of it, so hopefully if anyone's interested in seeing it, then just let me know. And thanks again, and see you all again sometime.
Thank you. Have a nice day.
Cheers.
Ciao.
Thanks, Claudia. Thanks, Don.
Grazie.
Thank you.
Thank you.
Federico.
Bye-bye.